Namaste student. Today we're going to see a proof of ASA congruence criterion by using postulate SAS. So here we have four criteria: SAS, ASA, SSS, RHS. So we're going to see the proof of ASA using SAS. So let's recapitulate SAS. Here two side and included angle, two side included angle, that means SAS. Then we can say that these two triangles are congruent. Okay, we'll use this concept and we'll try to prove ASA. Okay, so let's see. So in this criteria, what they have given here that two angle and included side, two angle and included side are equal, corresponding. So here we need to prove that ABC congruent to DEF. So here you can see that angle B equals to angle E, angle C equals to angle F, and BC equals to EF. This one has been given. Okay, now to prove SAS, either you take AB equals to DE, show this one, or AC equals to DF. If we'll take AB equals to DE, if we'll show this one, then you can say that SAS. Have you seen? By this criteria we can say that these two are what? Congruent. Okay, or you take AC equals to DF, you can say that SAS, these two are already given, just you need to show that AC equals to DF. Okay, so we'll take only one side, AB and DE. Then there may be three possibilities. Okay, let's see. So we'll start with the proof. There are three possibilities. Okay, the first one may be what? AB equals to DE. Second one, AB must be greater than what? DE. And the third one, AB less than DE. So what do we mean that? AB equals to DE. We'll take first case. In second case, what may be? AB is greater than this one. That means there must be P or a point P which will be equal to your DE. That means PB equals to DE. And the third one will take AB is smaller than DE. That means if we extend this one somewhere at point P, then PB equals to DE. That is the third case. So let's go with the first case. So case 1. Okay, case 1, when AB equals to DE. That means we can see that in triangle ABC and DEF, what we can see? In triangle ABC and DEF, AB equals to DE by assumption. Okay, we have assumed this one is equal. Second one is what? Angle B equals to angle E, given. And the third one, BC equals to EF. You can see that this one SAS. Therefore, we can say triangle ABC congruent to triangle DEF by SAS. And the theorem proved for first case. Okay, if your AB equals to DE. Let's go for the second one. Okay, so here we have second case. If AB is greater than DE, then what? If AB greater than DE, then Then what? PB must be equals to DE for some point on AB. That means there should be some point P which must be equals to this one equals to this. Okay. If your AB is not equals to DE, then there must be a point P such that PB equals to DE. Okay. Then what happened? Then what? In triangle, if you'll see in triangle ABC and triangle DEF, you can see that PB, this one in triangle, not ABC, sorry, PBC, you can see that PB equals to what? DE. Next, angle P equals to angle E. Next, you can see that BC equals to what? EF. Therefore, triangle PBC equals to triangle DEF by SAS, because these things are given. Okay. This imply by definition, if these two triangles are equal, that means their corresponding angle must be equal. That means we can say that angle PCB, that means this one PCB, this part, okay, PCB must be equals to, look the corresponding part, PCB, that means DFE, and we write here by CPCT, corresponding part of congruent triangle. Okay. So but what you can see, it is given in the question that whole thing, that means angle C must be equals to angle F. It is given that angle ACB equals to angle DFE. This imply ACB must be equals to, look at here, these two are equal and this one is equals to this. This imply PCB. How could it possible? See here, B match, C match, and A is not matching. It's not possible. How could you say that these two angle must be equal? This is possible only when, this is possible only when P coincide with A. That means this is nothing but a A. This can't possible. P should be A. Therefore, AB equals to DE. And in first case, we have seen that if AB equals to DE, this imply triangle ABC congruent to triangle DEF by SAS, and hence the theorem. Okay. Now we have third case. Let's see. So here we have the third case. If AB less than DE, that means there must be a point which is outside of AB, and if we'll extend this AB and if we'll take the PB, then this PB must be equals to your DE. Okay, if AB is not equals to DE, then there must be a point P. Okay, so let's take, that means if here in the third case, if AB is less than DE, then what? Then PB must be equals to what? DE for some point P on extended AB. Okay, extended. You have already extended this AB to outside, so this is your extended AB. Then what? Go to the back. Second case, same rule. This will give you, that means directly, see here, PB equals to D, that means this one will give you this result. So directly you can write here this imply triangle PBC congruent to triangle DEF by SAS. Okay, this imply, again same rule will apply, PCB must be equal to DFE by CPCD. Okay, but what we know, angle ACB equals to angle DFE. Okay, given this imply ACB equals to what? These two are equal and this is equals to this. This can be written as this way. Okay, this is, again we can say that this is possible only when A or P are coincide. That means P coincide with A. Therefore, AB equals to D. Hence, triangle ABC congruent to triangle DEF by SAS. Okay. Try to repeat this video again and again. I hope you will understand. Okay, it's quite lengthy, I know, but you can do. Okay. Thank you.